Same thing with, how about the x squared? What's the domain of the x squared? Yep. What about the range?
0.
Yeah, the range, you look at the height, right? So it starts from 0 to infinity. That's why for square root of x, if we talk about real number, we only consider from 0 to positive infinity. Right? This one, what about this one? What's the domain? Everything, right? All real number. What about this one? The reciprocal, 1 over x. In calculus, we call this the harmonic series. Well, I mean, if you put something in front of it, this is just a function. I add something in front of it, it's called harmonic series. But what is the domain of this one? Look at the left. Okay, the left, it looks like from negative infinity up to 0, right? At 0, the function go crazy. It's kind of go down to negative infinity at the y-axis. So this blue graph right here never touch the y-axis. It gets very close, but never quite touch it. Right? So not 0 from the left, and then we're gonna jump to the 0 from the right here. Again, this blue graph never touched the y-axis. The positive y-axis. So no 0 on the right either, right? So no 0, everything but 0, right? Everything but 0, because at 0, the function going crazy, right? On the left, it goes to negative infinity. On the right, it goes to positive infinity. The absolute value, y equals f. Y equals square root absolute value of x. It's kind of similar to this one, except you make the graph a little sharper, like a sharp T. Domain, everything range from 0 to infinity. Now, by the way, I'm talking about basic functions, okay? If I add number to this, it's gonna shift, and then the range is gonna change, right? But the basic function, that's how they look. Here is the square root of x. Sometimes, instead of writing square root of x, I can write x to the 1/2. It's the same thing, right? X to the 1/2 is the same thing. In your calculator, you can't find the square root of the square root button. You can do x to the 1/2, or you can do like say 9 to the 1/2 will give you 3. And do you guys remember how to do this? The rational exponents. This we talk about this one, x 1/2. Where does it come from? It comes from the index. Index here is the square root, which we don't write. It's kind of like 2. We say 2 over 1, right? It's just 2. But if you say 3, math people think 3 over 1, right? But we never put that 1 beneath just because conventional sense. For the numerator, the 1 is going to come from the exponents of the x. When I took this class as an undergrad, I had a teacher. He called this the good method. He kicked that 2 over and the 1 go up top. The good method. I don't know, it's easier for me to remember. So 1/2. If the index is 3, like cube root, so x to the 1/3. Right. 1/3. The exponent is still 1. For the graph of the square root, it's go from 0 to infinity. We'll talk about this. Why don't we take this part as well? Why are we missing this one? Yeah, if I have say y squared equal x, no, don't write this down. And then I take square root both sides, and then I have what? Plus and minus, right? So this is y equal positive square root of x, or y equal negative square root of x. So y equal negative square root of x, so 1 in the black graph I draw there. The reason we don't add it because the one-on-one function properties, and we'll talk about this. And here's the reciprocal square. It's kind of less popular than the rest. The domain is everything but 0. And the reason we don't care about the negative height, I call y values height, is because the square. Everything square can become positive. Why don't you take a second? I want you to take a second. You gotta do this on your own. Identify the type of each function based on the basic function given. So do that one. Maybe I'll just take a moment to do that one. For those of you who watch this video at home, you can fast forward when I stop. What kind of function do we have for the first one? Yeah, square root. Second one, yeah, cube. This is not bad, right? It is not bad. Third one, Q, C. Oh, D should be D here. The absolute value, right? Yeah. Yeah, thank you. Here, we're not graphing, so I'm not gonna talk about the shifting. E. It's the simplest function and it's one of the most powerful functions if you take that course. When I did graph study my first year is just linear function. We beat it to death. And still I haven't learned it all. F. Reciprocal. G. Quadratic, very good. Quadratic. I would say cubic here. Cubic function. H. Yeah, reciprocal square. Reciprocal, I miss an I. Reciprocal square, and then I. It's not wrong, but I want more precise. It's a line. Well, yeah, it's a line. It's linear. What kind of linear function? Y equal 2. Yes, constant. Vertical or horizontal? Horizontal. I know it's weird. We're like, oh, y equal 2. Y is vertical. It must be vertical, but it's not. It goes through 2, right? 2 is y. So horizontal. So the constant is a constant function. And it's a horizontal one. Horizontal. So far, so good. Relation. Very simple. Relation is any set of number that has order pair x, y. I don't care what x is, what's y. Well, we talk about real number here, right, or r. As long as their x and their y is called the relation. That's it. And the x values make up, let me highlight in yellow here. The x value make up the domain and the y value make up the range. We don't, in this class, we mention it, but we don't really study it much. But what we study is a function, right? Now, function is a little bit trickier. Function is a set of ordered pair. It is a relation plus each element of the domain corresponding to exactly one element in the range. That make it a little bit more picky. This implies, don't worry on the exam. I don't think they're gonna test you with the definition, but you can understand. Function means your x values cannot be repeated. Like I said, right? It like it says, each element in the domain means the x value, corresponding to exactly one. So there's only one x for every y. I'm not saying one x for one y. One x for every y. Y can be repeated. It's fine to be repeated. How do we know it's a function? Well, you can list it out x, y, and then if x is not repeated, then it's a function. But it's not a very practical way to do. So we have a test called vertical line test. Your vertical line test, if you could draw any arbitrary line, just randomly draw a line onto your function. It should not cut your function more than once. Then it is a function, which just makes sense, right? I'll give you an example. So for example, this one, let's just take a look at 2a. Why this is not a function? But let's take a look at the list first. This is the list. The list, I'll highlight it in green. Let's take a look at the list. It is not a function because, yes, x repeated it, right? So 2 twice. So 2 map with 2 and then 2 map with -2, right? So 2 repeated. And you can see if the same thing happened for when you map it out. So that's the map. So here you map it out. So that's your map. You can see. Now the third way, so one way you can list it out, you can map it, or you can draw the function, even if you know what it is, right? Here is the, you guys know what the function is? Huh? Yeah, it's not a function. You're right, it's not a function, but you know what it is in terms of relation. Yeah, quadratic is sideways. Quadratic is look like this, right? It's like a U, and here the U is sideways. So instead of y equal x squared, it's going to be x equal 1 squared, right? Right, x equal y squared, which is not a function. Then we talk about x equal y squared right here. Y squared equal x, or x equal y squared. Right? And the reason they restrict it because it needs to be a function. Right? So you can draw a line, a vertical line. Maybe I'll use red. And you can see that it intersects the function twice. So no, not a function. Is it a relation? No, I'm not one-to-one yet. Is it a relation? Yes, right? Relation is very easy. As long as you have x and y, it's a relation. I don't care if x or y repeated, right? So so function is a relation plus x is not repeated. Okay, that's all you have to know. That's all you have to know. And of course, remember the vertical test, which is makes sense, right? Maybe let me move my line to a little bit to the left, where it intersects at 2 right here, right there, right? At 2, if I look up, it project over 2, right? If I look down, look over, it project over -2. So 2, 2, 2, negative 2. So it's consistent with the map. What about C? It's a function, right? It's a function because x is not repeated. I'll say yes. It's a function. D. Yes, right. If you can draw any vertical line test and it passed that vertical line test, so yes. E. What about E? Yes, right. Yes. Now, but let me go back to C a little bit before I move on. Some people argue C is not a function because 3 is repeated. But 3 is the y value, right? As long as my x is not repeated, I'm okay. But y can be repeated. That's all right. That's all right. So it's still a function, even though 3 is repeated for y. E, yes, right, is good. Nothing repeated here, isn't it? No. So yes. F. Function, right? By the way, that's this part right here. This part right here, you see, maybe make it a little bigger. This part right here, you see, it's not a straight line. It's not like a vertical line. It's kind of slanted a little bit. So when you draw a vertical line test, it still only cut the graph at once. You try one. Take out your computer, your laptop, or your phone is fine. Make sure you'll be able to see the you try. Determine whether the relation define y to be a function of x when we say y is a function of x, means y depend on x. Whatever x is, you plug it in, that will define y. Right? So here, x is the input value and it's independent. You can choose anything for x. Right? But however, y depends on it. Right? When you put x into the function, is called the output. And we call and the output y is the dependent variable, so it depends on x. So y is a function of x is f of x. If I say a is a function of x, so how will you write this? Huh? So you don't have to write this down. It's just testing your understanding. So y is a function of x. We write it like this: y equal f of x. So a is a function of x. It'll be a equal f of x. B is a function, right? B equal f of x. Or sometimes people be lazy, they be writing like this, b of x. It's not wrong. It's not wrong you do that. My point is that when I say something like that, you should be able to define what letter is going to be your range, which is your y. What letter is going to be your domain, which is your x. Okay, that's all I want you to get out here. So. All right, let's try. Let's take a look. The reason I mentioned that because later you see when we do this problem. Each equation below represent relations. Determine whether each relation represent y as the function of x, meaning x is not going to be repeated. Right? Means x should not be repeated. So if you take a look at the example right here, you can take a look at it. I'm not gonna, you know how to read. It's a function because when you solve it, it's a function because you only have one x value for every y, right? When you solve for x, well, when you plug in x, say when I plug in 0 for x, 2 times maybe 2 times 0 is 3, so 1 3. I plug in another one. There's only one y, right? When I plug in another one, I have another value for y. And besides, even if you don't solve for this, what kind of function, what graph does this function have? Linear, right? So linear, remember linear is just a line. So when you draw a vertical line test, you only cut the line once. What about B? What about B? Before we do that, I would suggest you solve for y. Y equal 1 over x. That's the reciprocal function. Is it a function? Well, as long as x cannot be 0, right? You can't divide it by 0. It's a comma. Is it a function? Yes, right, yes. You can type by vertical like that. Now, if you accidentally draw a vertical line test that map the y-axis, it doesn't cut the function at all. But that's okay, right? We just say as long as it does cut twice or 3 times, we okay. So yes. What about C? I'll give you a moment to let me know. What do you think about C? Yes, right. Yeah. So let's, if you like, you can solve for y, x squared minus 1. And y is going to be repeated, right? Say when you do a little t table, you plug in -1. -1 squared is 1. 1 minus 1 is 0. And then you do 1, it's still 0. Y repeated, but that's okay. Right? It's a function. As long as x is not repeated. And then you can test with the vertical line test. So only cut it once, whenever you draw it. Right. Yes. What about D? Yeah, we talk about this, right? Y squared equal x or x equal y squared is the parabola sideways. Cut it twice, or you can do a little t table.
When x equal 1, y is 1. When x equal well, if I do negative, I'm gonna have a let's do the larger value because um let's do y first. When y is negative 1, x is when y negative 1, x is 1. When y is 1, x also 1. Right, so 1 map to negative 1 and 1 map to 1 is repeated. No. So far, so good. Yeah. Oh, you maybe I'll use black for this. So when I plug in negative 1 for y, negative 1 squared equal 1. When I plug in 1 for y, x is also 1. So this is like a flip version of, usually you plug in x first, right? But it's just easier for you to do y first. If you want to do x, you want to do y, you can do like this. If you, do you think is this weird? You can do like this. You can solve for y. We talked about that, right? Square root both sides. Square root, you put plus and minus. For the letter, I don't know. If it's a number, you don't have to. If it's a letter, and now you can do t-table. X and y. When y equal 1, what's x equal? I'm sorry, when x equal 1, what's y equal? Yeah, either positive 1 or negative 1. Right. So it's the same thing. Anything else? Anything else? Please ask. Don't be shy. For A, here is the table. The first row is percentage grade, denote G, and the second row is grade point average, denote A. Again, just letters, just placeholder. The first row will be your X, the second row will be your Y. That's all you have to understand, right? So this will be your domain. And this will be your range. I use XY because that's how you perceive domain and range. Is A is a function of G? Yes, why? Yes, don't repeat it, right? Say from 0, let's take a look at the first one. X value, I have the range from 0 to 56. So 0 maps to 0.0, which is 0. Right. So I see 0 map to, I'm talking about 0 to 56. Here 0 map to 0, and then 1 map to 0, and 2 map to 0, all the way to 56 map to 0, right? Even though y repeated, but that's okay. X is not repeated. And similar with this one, right? Is same explanation. So so yes. Oh, I shouldn't say x value. I should say g value.
Do you have any question? Can you see it? If you don't see it, try to dissect it. Just do like I did there. What about B? What about B? Hmm? Huh? It's a function? Who say the function? Raise your hand. Function. Not a function? What about the rest of you? I'll wait for your answer. uh, it's not because again, this is your x value, right? This is your y value. They just use different letters. So here, x is gonna be A, y is gonna be G. So let's map them. Let's take a look at the first one. Let's take a look at this one. So 0 map to 0. I'm talking about counting number. There's 0 0.5, 0 0.7. I'm not gonna care about that, okay? 0 map to 1%, right? 0 map to 2%, all the way to 0 map to 56. And same thing for the second, and third, and fourth, etc. Right? So as you can see, x repeated, or rather A repeated. Because so far so good. Here they use the capital F. If you use the regular F, that's fine too. Then you try to make it different with the G, little a, that's all. But if you want to use little f, that's all right. Given function 2x squared minus 4x plus 1, and I want to evaluate where x is -2. So what is y? Looking at the function, and then you can spit out y. Let's try f of 2x. If I was you, I would replace. So everywhere I see an x, instead of x, I'm going to replace with the new x, which is 2x, right? So your new input is 2x. So I have 2 times the new input square. So everywhere I see an x, I'm going to replace with a parenthesis, right? Minus 4 times parenthesis plus 1. And now I'm just going to plug in my new values, my new input, which is 2x. So you don't make mistakes. A lot of times people just kind of square the x, but it's back to square the 2 times 2x squared is 4x squared minus ax plus 1. Finally, 2 times 4 is 8. Ax squared minus ax plus 1. You guys are freaked out, so I don't expect you to do this. So people will just distribute the code. You only do that if between 4 and x squared are plus or minus. It's one term. 4x squared is only one term, so you only multiply it once. It's kind of like this: 2 times 5 times 3. Well, either you take 5 times 3, which is 15, and then times 2, so 30, or don't write this down. Or you can multiply the 2 with the 5, which is 10. 10 times 3 is still 30, right? So only multiply it once. The reason I brought it up because in the exam people got panicked and they just remember what they remember privatively. It's a silly mistake. Use part B to solve f of 2x equals 17. So we know what f of 2x is. This is f of 2x right here. That's f of 2x. And then I'm going to let it equal to 17. I'm going to solve for x. Equals 17. Why don't you guys solve it? I believe everybody can solve this. My only concern is your presentation, which lose you point. That's I think that's how those people say, oh, you that department is terrible. I heard that, sure. Well, they're not terrible, but the thing that they're looking for your presentation. One thing about math, right? You can get the right answer, but you don't have the right presentation. Just they deduct points. So many problems deduct many points is add up. So don't lose those silly points. So if I was you, I move 17 to the left. So I see ax squared minus ax minus 16 equals 0. Factor out the 8. If you have a GCF, do factor out. It'll help you make your life easier. So x squared minus x minus 2 equals 0. Divide both sides by 8. That's just 1. That's 0. That's 0. So I have x squared minus x minus 2 equals 0. Is it factorable or no? Yeah, right. So you don't need to use a quadratic formula. 1, 2. I need negative x, so -2, +1. So x equal 1. I'm sorry, x equal -1 or x equal +2. Hmm? Say it again. Oh. Okay, let me do one more step. So so I have x plus 1 equals 0, or x minus 2 equals 0, right? Subtract 1 both sides. Here you add 2 both sides. Let's cancel. So x equal -1 or x equal 2. Now I have 2x value, but is it a function? Yeah, right. It actually not repeated, right? X is 2 different values. It mapped to
it mapped to what? What the negative 1 and 2 map to? Not 17. When you plug in negative 1 and 2, what happens to the function? It becomes 0, so it's mapped to 0, right? So y is 0. So negative 1, 0, and then 2, 0, even though 0 repeated, but we don't care because it's the y values. So it's still a function. This is the x-intercept. Yeah. C and D. Yeah, let's do C and D before we run out of time. F of x plus 3. So if I was you, again, I'll do like that. So F, if you have color, maybe it helped too. And then let's rewrite that parenthesis thing. So 2 times parenthesis square minus 4 times parenthesis plus 1. Is that the function I'm doing? Yeah. So now your input, your new input is yes. Huh? Oh. Oh, I sent it out last. I sent it out last Friday. But they updated the window. That's all right. That's all right. Practice with me, right? Sorry. Yeah, I just got an email. They updated it a little bit. You can FOIL it x plus 3 times x plus 3. What I don't want to see, especially pre-calc students, you just use the square to teach the term x squared plus 3 squared. Don't even do that. Okay, that's just 0. No partial break for those, right? So if you FOIL it, what do you have? Do you remember? Yeah, x squared plus 6x plus 9. What I remember, this is how I remember. I know it's not right, but it just help you, just faster than both. So x squared, distribute the square, I won't distribute the x squared, and then 3 squared, which is x squared is 9. And then the middle one will be what? 2 times. The exponents become the number now, 2 times x times 3. And it's true for every binomial square. Minus 4x plus 12 plus 1. Distribute the 2, so I have 2. Minus 12, thank you very much. 2x squared plus 12x plus 18 minus 4x minus 12 plus 1. Combine like term. I have the 12x and the negative 4x. That's positive ax. And then I have the 18, the negative 12 and the 1. 7. That's your answer. Why don't you try D? Just try D. Try D, okay? And then we have you try 2. Do you have D on your thing? No. It's important. Just do that one. Just try D. Yeah, I know why. When Tom complained that this one could be kind of, you expect that on the exam, kind of. Right? So someone expand x plus h squared for me. Yeah. Just read it for me. Just x squared what? Mm-hmm. Yeah, you distribute the two. Yeah. So 2x squared plus 4xh plus 2h squared.
Like I said, right, the fast way is instead of plugging, you x squared, and then h squared, and then the middle term is gonna be 2 times x times h.
Minus 4x minus 4h plus 1 minus 4x minus 4h plus 1. That's my favorite part. Take out your 0 pen. Cancel them. 2x squared. It's nothing I cancel, so we write that. Oh, is there anything I can cancel? No. No. Oh, I remember wrong. There will be canceling if there is quotient, but we don't have quotient, so we're done. You try to, if you open up your Cal laptop. I'm not gonna write everything. I give you the function on the Moodle, but I want to evaluate. So dot 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 at f of -2. Open your thing. You should have it. Maybe I'll write everything out here. I have f of x equal x squared plus 3x minus 4. Yeah, evaluate f of -2. We're not done yet. It's a little bit more, and then I'll let you go. This will be should be quick. This should be quick. This is just eyeballing a sample. All right. All right. Here's a graph.
When you see the little solid dot, it means the function stop right there. So for example, on the domain, the function stop at -8, and then all the way to 10. Right? So the range, the function start at -2, the height from -2 up to 6. So
The dot means it's not go on forever. It stop right there. So what's f of 4? When you eyeball 4, what's the height? 0, right? Right here, 4 right here. So f of 4, 0. What's f of -6? -6. 3 right here. Right, 3, thank you. What value of x does f of x equal 4? So they give you the height, they want you to find the width. They give you y, they want you to find x. So 4, let's see, 4 right here. That's 4, right? And you can do like that. So where does it cut the function? -8 and 9. Yeah, -8 and 9. Yeah. Sorry, I know it look. I should have put like this because it doesn't look like a x equal 8 like a horizontal. It's the coordinate. It's not a function. So put the little curly bracket mean it's a set of number 8, a -8 and 9. For what values for what values of x, the f of x equal -2. Yeah, 6, right? So 6. Then I do curly bracket like that. Phi f of -2 and f of 10. F of -2 is 2, f of 10 is 6. Thank you. How does up on the line y equal 3 cross the graph? Y equal 3. Y equal 3 right here. Twice, right? Twice. So it's cross so twice. Just say twice. Just say twice. Is f a one-on-one function? Oh, I'm sorry, I forgot to talk about one-on-one function. One-on-one function is even trickier than function. Remember, function is a relation as long as x is not repeated, right? One-to-one is x cannot be repeated and y cannot be repeated. So a little bit pickier, right? So to test the one-to-one function, we use a horizontal line test. So instead of vertical line, it's going to be horizontal line. Is it a one-to-one function? No, right? Because yeah, if you grab it right there, it cross the interval from -2 to -2, right? So it's crossed infinitely in any point. So nope. Almost there. Well, no, we will continue next time.